On the unit circle, people are generally less familiar and comfortable with the tangent values than they are the sine and the cosine. So one thing that I do expect people to know, and most people do know, is that tangent of some theta is equal to sine theta over cosine theta. So in theory, you could go find all the sine values, find all the cosine values, divide them, and simplify. But what I want you to remember is that the sine values are the y values. So this sine theta is like looking at the height. The cosine values are the x values. So this would be like a change in x. The height is a change in y. And if you look, change in y over change in x, the tangent values are very simply the slope of the radius. So some of these are very easy to get. Here's the origin. If I go to the right, the slope of this radius right here is 0. And frankly, this radius and this radius are really on the same line, so the tangent over here is 0. Now if you look up and down, this is not a 0 slope. It's actually an infinitely steep slope, and some people say and have learned that it's undefined. So we would say it's undefined, and a lot of people use the empty set symbol for that. I would say it's probably more accurate to say it's undefined, and as we study limits more, you could say it's infinitely large. Okay, so other slope values. Well, if you look right here at this one, this is when sine is square root of 2 over 2 and cosine is square root of 2 over 2. The rise and the run are exactly the same. So when you divide those, or if you think about a 45-degree angle, that would be a slope of 1. This line is the same as this line. It also has a slope of 1. And a lot of people get the signs confused, like when is it positive, when is it negative? Just look at the radius. From left to right, is the radius going up or is it going down? The radius is going up the whole time in this quadrant, so all the tangent values will be positive. In this quadrant, it's going down from left to right, so all the tangent values will be negative. In this quadrant, the radius is going up, positive. In this quadrant, going down. So these two values right here and here have the same slope as this line, but this line's going up, this one's going down. This is a -1 and a -1. Okay, there are two values left that we have to look at. So they are the square root of 3 and then the square root of 3 over 3. If you actually flip one over, you get the other if you simplify. Like 1 over this would be that. But if you take a look at these, remember that these are slopes. The steeper the slope, the higher the number. This number is 3 times that number, or you could say this is a third of that. So this is the shallow slope, and this is the steep slope. So this line right here is shallow, this one is steep. The radius is going up from left to right, so they're positive. This is square root of 3 over 3. This is square root of 3. This is steep, but it's going down, so negative square root of 3. Shallow going down, negative square root of 3 over 3. Shallow going up, square root of 3 over 3. This one is 1. This is steep going up, positive square root of 3, undefined. Steep going down, negative square root of 3, -1. Shallow going down, negative square root of 3 over 3. And those are the values of tangent on the unit circle.